So I'm going to chat a bit about learning and teaching modern C++. I have thought, since this is right after lunch, I wouldn't do too much code. In fact, I think I have written about 2.5 lines of code myself, and the rest is 1 or 2 screenshots, so really not much code in this. And it's more like a philosophical topic anyway. So, what is modern C++? I think this is a question we see very often online, very different explanations. This actually is a question asked by Jens on Twitter. He sometimes does polls on Twitter, so they're not very scientific. You see 375 votes, so it's not of statistical significance, but hey. Let's talk about all the 4 different options he has here. New standards and boost, or only new standards, larger or equal to C++11. Ask Alexandrescu. Maybe not everyone in the room still knows what that is about. Or just using C++ to its fullest. I'll start with the first, I think. When we look at the new standards, they only define what is possible, not what is good. So we have backwards compatibility, so we still can write new, freestanding new and delete. We can throw around void pointers or use plain C arrays. We can still write C with classes like this was on vogue end of the 80s. We can write Java for the C++ compiler, which was very much done so in the early 2000s, I think. So put everything in huge class hierarchies. This will compile. You probably need a C++11 or C++14 compiler for it if you use one range-based 4 somewhere. It is standard compliant, but it's not really what we think about what is modern C++. It doesn't have this modern C++ feel. So if we talk about modern C++, we really do not only talk about the new features of the new standards. And well, for the other option, if we add boost to the mix, doesn't change anything that the old stuff is not modern. So the first 2 options, I think, not the answer for me. Then we have the next one, Ask Alexandrescu. There was a book in 2001, that's 15 years ago, and it was called Modern C++ Design. It was very focused on templates. Alexandrescu did very interesting stuff in there, like policy-based class design and adding policies to have different behaviors in smart pointers, and a lot about allocators and really interesting stuff like type lists and compile time assertions, which are in the standard right now. The type lists we have kind of with variadic templates now. But as I said, it was 2001 and the language has evolved since then. And it is a good read. It gives good impressions of what we can do, how we can compose classes in a generic way. So all this template metaprogramming stuff he started in there still is valid, still is good C++. But it's not so modern anymore because we got those new features and well, C++ has moved on and templates is not the only thing about C++ that can be modern, so we have other features as well. So this one is gone as well. So in this poll, I checked the using C++ to its fullest, whatever that may mean. And what I think modern C++ is what we consider best practice right now. We have played around with the language features a lot, and sometimes we overuse them, like Arne said in his talk. Sometimes we have to turn back and use them sensibly. For example, there was, in the early days of Auto, there was a blog post by Herb Sutter where he proposed one should consider to use almost always Auto. But if you look into the net now and look for almost always Auto, then there are several blog posts and talks about that always or almost always is not really the thing to aim for, so to dial it back a bit. And the old features also matter still, so the great thing we have that many other languages don't have the destructors which enable RAII, which is still a modern idiom to use. So we have to combine the good parts of the old features and the good things of the new features to write in a modern style, I think. That's why I added this generated O'Reilly style book cover as in response to Jens Paul. This book doesn't exist actually. If I was to write this book, I would actually add a chapter called The Good Parts to explain why the good parts. When I was a young programmer, I would learn about all the features in the language. I would use them, all of them, in every program and kind of showing off. And I think I actually did this, and it worked because you have other people who think, hey, that guy is smart, and I kind of can ask him about every feature. And well, I think almost everyone will know such a guy, either being himself, having himself been such a person, or know such a person in the team or somewhere else. Eventually, we figure out that just using all the features just because we can doesn't hit the mark. So it's not the right thing to do. So we discover that some parts of our programming language is good, some other parts are bad. So we have to figure out which are the good parts and avoid the bad parts. The problem is that there are so many proposals to just remove the bad parts from the languages. But hey, the Standards Committee has always this thing for backwards compatibility, so they can't just remove anything from the language because it will break code. That's what we hear since forever, I think. And this will be a problem in the future, like forever also. So what we have to do is define our own subset of the language that we want to use and leave the other parts aside and do not use them, or know when to use them and to use them safely and sensibly, and not just use everything we have at our disposal, but to know which parts to use and which parts to leave out. Sadly, I could not write this preface because it has already been written in a book named JavaScript, The Good Parts, which does essentially the same about JavaScript. We have there's a meme going around on the internet with two books aside, JavaScript and JavaScript The Good Parts, which is about a third the thick. But that's actually the same thing is valid for C++, I think, and probably for many other program languages. And I think these good parts is, I think Bjarne also mentioned it, is this smaller, more simple language that tries to come out, that we get with the new features, we get the ability to use this smaller language, but also by using those new features sensibly, so to not overuse them, like he also said in his talk. And then the next problem is that modern C++ is a moving target because, well, we get new features in the language. We get currently every 3 years a new standard with new features, with features we can newly use to yet more improve our code. We have the technical specifications where we can play around with new features before they get into the standard. But that doesn't mean that modern C++ changes every 3 years when we get the new standard. It also changes when we discover how we can use the new features. So basically, modern C++ of today is not the same as modern C++ of tomorrow. For example, there was something called universal references. Does someone know the term? Does someone else know the term forwarding references? Universal references was a term coined by Scott Myers in his book Effective Modern C++, which came out early, I think in 2011, right after the 2011 standard was published. And I'm not sure if Scott participated in the paper or not. 2 or 3 months later, many people sat together and wrote a paper that it shouldn't be named universal references, but forwarding references, because it's what the forwarding references do. So we have a book that talks about universal references, and the understanding of C++ changed. In this time, it's only a name. But we have also this notion of almost always auto, where Herb Sutter proposed to try to use the auto W is a widget, my widget, instead of widget W, my widget. He didn't say we have to use it this way, it's better this way, but he wrote a blog post about how it has its benefits and its trade-offs, and that we should maybe try to use it and see how it goes. And well, in the last years after that, there were many blog posts and conference talks about how this almost always auto, this second case, maybe is not the best thing to use. So many people went back to the first option. So with this moving target, it's not quite easy to hit the mark if you teach someone C++, and what you teach today is what was modern C++ yesterday, but the understanding already moved on, and modern C++ is something different today. There's yet another problem with modern C++. We use C++ in very different areas. We use it on microcontrollers, on embedded devices, on really small machines. We use it in cloud computing, on mobile devices, for high-performance computing, game engines, and just plain boring enterprise business software. And the needs for all these kinds of software are different. So what is really necessary to use in C++ and what is good in modern C++ may differ between these areas. For example, in enterprise applications, we can use smart pointers and everything, but they come at a cost, but they are good C++ if we can afford these costs. On other areas, like on embedded devices, we cannot afford these costs, so the focus is very different. So we don't have one, but several moving targets we have to take into account. For example, consider the usual sales pitch for RAII. The usual argument, the first thing you hear, it's for exception safety. The usual examples are unique pointers for memory, lock guards for mutexes, F-streams or for files. And if you go to a person who scratches a bit on the bare metal and gets some bits and bytes out of it to make some magic, they don't have exceptions. They don't have memory, or not much. They have a single core, so they don't need mutexes because they don't do multi-threading, and files not so often. So this whole sales pitch is, well, if you go to an embedded person who doesn't know the RAII and tell them you have to do RAII because of this, they say, well, I don't need this. But still, also on embedded devices, if you have early returns, for example, and have some other responsibilities that you have to clean up, RAI is still a good idea, but you have to tune your teaching and your argumentation to the person you're talking to the needs they have. And there's yet another challenge. Usually when someone is teaching C++, they have some experience over the years. And I think most of us will have learned C++ by learning maybe C first, maybe C++ 98 first. And then bit by bit, we got the changes. We got in the early 2000s, we got like smart pointers were the new thing. Then we got in C++ 11, now C++ 14, and it will continue. We have like a layered evolution of C++ in our minds. So what we have seen first is, for us, is naturally the first thing we talk about. And if we teach it that way. Our students and the persons we talk to will get the same layer of information and think the same way about C++ like us. But this is often this is just too much boilerplate to think about, too much things that are not relevant anymore. So we have to teach, right, this is modern C++ and not this path through our memories is modern C++. For example, it might be a good idea to start with make unique and unique pointers right away instead of first talking about, well, there was once new and delete to get some memory and to free it. And you have to take into account that you don't mismatch new and malloc and delete and free and the single point object versions and the array versions. If you just start with the unique pointer, new and delete, for starters, goes away. You can then later go on to, if you write your memory allocation class yourself, your smart pointer, your own smart pointer, then you need new and delete. But today, in modern C++, we say freestanding new and delete is not a good thing to have. So this is still something people have to struggle with, people have to keep in mind if what they are teaching is actually their perspective of the past of C++, or if it's C++ from today, the modern C++. The adoption of technology and of new standards and so on takes some time. So we kind of live in our own bubble where we see lots of people using C++ 11, C++ 14, and often people in our bubble tend to think, well, everybody is using C++ 11 now, besides maybe a few people who lag behind. But I don't think it's really the case. I think most of us live in a bubble on the left part. And there are so many developers you don't see online, you don't see on conferences, you don't see anywhere. They've been called dark matter developers because you know they are there because there are like 7, 8, 9 million of C++ developers. But if you look like any person who has ever attended a conference, any person you find online, you find in blogs, you find on Twitter or somewhere, the C++ developers, maybe they sum up to 100,000. That's much, but it's not a percent of what could be there. I said I like Twitter posts, right? I myself did a small poll, again, statistically significant with 469 votes, about how people learn C++, where they learned most of C++ from. The majority is from books. Very little, actually, surprising for me, had their major source of knowledge being their teacher or professor. Online tutorials and blogs, of course, there are a lot of them, and some others that I come to. I think teachers and professors only get you so far, and if you want to learn more, you turn to blogs, you turn to books, and so on. And of course, these polls have a selection bias because the people that are following me on Twitter are mostly doing so because they're reading my blog. And so they are not the people that learned C++ on university and never touched a book or blog or anything again. So this is kind of naturally that the teacher and professor maybe is a bit underrepresented here. In the other options, we had things like learning from colleagues, reading code, reading magazines in the old times, where magazines were what today is a blog, I think. Usenet and more books. Actually, people sent me pictures of their bookshelves. It was quite funny. I go a bit over all the different options we have. Learn C++ in the classroom. There are some really good teachers out there. And if they really want to teach, if they are enthusiastic, people can really learn a lot from them. But there also are people out there that are maybe professor in a university and they want to do some research. But in some places, if you want to do research in a university, you also have to teach. So they are obliged to hold classes. And if this class is a C++ class, maybe they prepared the class once in 2000 and ever since hold the same class every year. So you can see that those people probably do not teach what we consider as modern C++. And that way you get students right out of college who don't know anything, or you would think about anything about C++ at all. They know what was C++ in the 90s or early 2000s or maybe it's even in the 80s. Actually, a year ago, I came about a blog post. Stop using Turbo C++. It was a year ago, and I wrote something like, well, stop using Turbo C++, that you should have written this in the start of the 2000s, but not now. No one is using Turbo C++ anymore. And he wrote, thanks for a comment. I agree that Turbo C++ is old and it should not be used. But in most of the engineering colleges in India, students are forced to use Turbo C++ in classrooms. Great, a new generation of legacy C++ programmers in the making. And actually, you see this kind of questions on Stack Overflow and in bulletin boards and so on, where people write, hey, I'm using Ball and C++ Builder. I'm using this, and I want to know how some strucat function is working. Well, why are you using those old C functions? We have C++ now, but you see this in these questions. But I think the dark matter programmers that are still using Turbo C++ might be still a significant number. The next thing is books. This is the bookshelf of James McNellis. We have some pros and some cons. Oops. The pro is usually if you write a book, you have like one line of thought and you continue from the start to the beginning. So you have one consistent chunk of information that makes sense as a whole. Usually books are also reviewed by at least 2-3 peers, I think. But not always. We have these, I don't know, I think it's called lean publishing, those things where you just can send your books and they print it and ship it out and no one has ever read it. The cons of books is they usually last longer than the validity of the content. So if you write a book today about modern C++, you can't write about concepts because concepts aren't in C++ yet. Maybe in 4 or 5 years we have concepts, then this book is old. And sometimes even, as I said, the understanding of modern C++ changes daily or weekly. So if you write a book today until it's shipped, until it's printed, there might be something you want to change because it's outdated already, or because you found out something new about the stuff you've written about. Often you see books to be promoted to make money. So there are books that are still sold today from 1995, 1996 around, which definitely are not about standard C++ and especially not about modern C++. And errors are hard to fix. It's really hard to ship a book out and recall it to fix some typos and some things you got messed up. There are errata pages, but I don't think that there are very many people who open a book and in parallel open the errata page on the internet to check if what they are reading right now in the book still is valid because the errata page says so. And another point that still does matter is that books are not free of charge. I know there is the argument that if you have a good book, a good piece of information, you should want to pay for it. But if you look at students who don't have much money, it's hard for them to buy books for about 200, 300, 400 euros or dollars per year. So it still is a topic you have to take into account that books do cost money and not everyone can afford them. This is a Stack Overflow question from 2013 about IO stream.h. Hi, I'm Rone. I'm using a book called Teach Yourself C++ in 21 Days. I had heard about this book before in a joke, like a small cartoon. The only way to teach C++ in 21 days is to learn like biochemistry first to get younger and to learn particle physics and quantum physics, then to build a time machine, then take about 4 or 10 years to learn C++, and then travel back in time and kill your younger self. This book is still available on Amazon. It's from 1997. There's another version from 1998, I think. So you can buy legacy knowledge for about $18 at Amazon. And this book has a lot of 5-star reviews, even from today, from some people who just want to sell the book and don't know what's in it, and that's everything what in it is outdated. There are other reviews who wrote, I tried about every example in the book and not even one compiled actually. Blogs and tutorials. This is the blog roll from meetingc++.com from last week. So these are only blog posts from 1 week, which Jens is promoting. There are thousands of blog posts more each week. So we really have a huge repository of knowledge out there, of things we can read. Also, there are some pros and cons. The pros are, other than books, blog posts are free of charge. So we can read a lot of them if we want to. Authors can fix things if they get outdated. They can take the blog posts offline if they think they are not valid anymore. The downside is usually we don't do that. I have a blog myself, and I sometimes, if someone writes a comment on one of my posts, here's an error or here's something to fix, and then I fix it. But I don't reread all the blog posts I've written in the last 2 years to check if they are still valid or if there are errors or if I have to add something new. So information can get outdated on blogs pretty fast as well, and on tutorials also. The other downside is there is not much reviews besides the comments of people who read it and find something that is wrong or should be changed. And they are not as coherent as a book. So if you have a blog post, today I write about variadic templates, the next day I write about const expression, and a few days after that, what testing frameworks we have for C++. So it's not one line of thought, and you have to gather yourself the bits and pieces that interest you and try to make sense out of all those single bits you gather. And also, this is from October 2016 from YouTube, a video C++ with Turbo C++, I think you see a Windows screen starting a DOS box, and then you get this. About 10 minutes with a bit of music, no explanations, nothing else. I don't know if there are people taking things like this serious, but if you have something that is not that extreme, but still that is outdated, bad, there still will be people reading it and taking it for granted and taking it for that what C++ has to be. And that's, I think, things like this are part of the reason why C++ may have a bit of a bad reputation as being complicated, as being archaic, and not as modern as other languages. So there's another tutorial I found about string handling functions in C++, strulen and strucat and strucopy and struref, and include iostream.h is my favorite. This is also written in 2016, I think, yeah, July 2016. And the author is not someone who learned C++ in the 80s. The author himself, right? He is a young boy who enjoys coding and passionate to make, break, and develop new codes. So that boy obviously has learned C++ from someone who didn't know what is modern C++, who also has old knowledge and is spreading this old knowledge. So I think this hints at a real problem. And as I said, we have these dark matter developers. So if you have teachers or professors forcing people to use old Turbo C++, it's just a mess. And it's necessary to do something against it, but actually I don't really have a good solution what we can do against it. But I think we as a community do have to try to get the word out there, what is modern C++ and what alternatives we have, and have to make sources available for people to see what we have now. We also had these colleagues and reading code. I think if you want to learn from just reading some code, it has to be extremely well written and documented very well, or else you really have a hard time to figure out what's going on. And you don't know if it's modern or if it's 10 years old often, so one has to be careful just learning C++ by reading someone else's code. As well, learning from colleagues, you have to have colleagues that are knowledgeable, that knows modern C++ and who you can trust in teaching you the right thing. But even if they do, you kind of have one view on the language, and all the other developers who learn from this single person have the same view. So it's like a bit of inbreeding. You don't get fresh ideas from outside. So only learning from colleagues and from reading code is not enough. I think we should expand our views and read blogs and go to conferences, listen to talks to get those fresh ideas. Well, and of course it's the same if our colleague we are learning the code from actually doesn't know modern C++, but is somewhere in the late 90s or early 2000s with his knowledge, then we know the same stuff he knows, which is also outdated. The next option were forums and Usenet, Stack Overflow. I think these are the three sources I used until now to learn C++ besides book. I got my theoretical knowledge from books, and then went either to the forum, at first it's a German C++ community, and after that to Complang C++ moderated just a bit, and Stack Overflow a bit more, to find interesting questions and try to answer them by looking things up in the net, in the standard, in the books I had. So it's quite nice to get a bit of practice and not just read the theoretical stuff. The really good stuff on those communities is that you don't have a single point of view, but that you have discussion. You write an answer, someone else writes a different answer, you start to discuss about which answer has its benefits, what are the drawbacks. So these are the places where actually our understanding of C++ is evolving. Obviously, in meetings and user groups and conferences as well. But if you have this exchange of ideas, is I think the point where actually modern C++ is moving from one point to the next. For learning just from blogs and Usenet and so on, I think it's not the only source you can have, because you have very specific questions that have to get answered, and even more like modern blogs, you don't have one continuous line where you can really learn a lot of things, but you learn small bits and pieces from here and there. And also there's very much noise because you get the same questions again and again, why iostream.h won't compile, and you have the trolls again and again who just want to see the world burn, so a bit of caution there. There are some more sources. We have the core guidelines, which can guide us to use a better C++ if we use, for example, a static analyzer like ClientTidy, who warns us about uses that, according to the core guidelines, are not so good. We can read the rationale on GitHub and read about why this use I had and the analyzer warned me about is not so good. And I think it's a good additional thing to learn from while I'm coding, while I'm writing my code, where I get direct feedback what I can do better. So what do we need for better learning resources? Also for teaching, of course. The authority or the single point of visibility is some place where we know the stuff we find in there is good. If you just search on Google, we get everything. If you search for cheap books on Amazon, we get C++ in 21 days from 1997. So we have to find a single point where we can get the information from. We have to need flexibility or even volatility, because, like I said, if you have a book that is outdated in 2 or 3 years, you have to have the possibility to tweak your resource to get in the new information when it is available. And this community aspect is also very important. So you have the people discussing about things and the different opinions, the different point of views, especially when you take into account these different topics that C++ can be used in embedded, cloud, and high-performance computing. Because if you have a question or have to get something answered, and you want to have a solution for your problem in embedded, then the solution the enterprise financial applications guy is giving you maybe a good solution for his domain, but maybe not for your domain. What we have is isocpp.org, which we didn't have start of the 2000s. We have it like 2010 or 2011, which is simply a hub for everything C++ related. You have a forum, we have a blog, which has also links to lots of other blogs, links to new books that are coming out. You have videos, also events, so you can on isocpp.org, I think you will also see Meeting C++ announced and other conferences. You have information about the standardization process, how it's going, what is actually, what they talk about, and you have a C++ FAQ. I think in the early 2000s there were 2 or 3 C++ FAQs in the web, and they have aggregated those on isocpp.org. So this could be a good point where you go and get your first information where to search from there. What we also have is cppreference.com, which is a really good and up-to-date reference about what is in C++, and you see which parts are part of C++ 11, of C++ 14, C++ 17, so there are small annotations, so you really see what is in there and what you should be able to use with your current compiler. You have a wiki format, so everything can edit the things. If something is missing, just maybe look it up in the standard papers if you have one at hand and add the information. And because of that, it's always pretty up to date. The downside is it's still only a reference, so well, you don't have like a book, like a textbook for beginners where you can start with Hello World and go on from them. You have a few basic concepts explained, but you don't have a reading order like you have in a book. So it's good if you have to look something up, something specific. How can I use variadic templates? How can I use don't know what? And it has executable code. So the code examples you have on cppreference.com, you actually can run them directly on the site. Then there's something new. I think it's about 2 or 3 months ago that Stack Overflow opened a new feature called Documentation Beta. It's a place where you can not, as Stack Overflow usually does, ask a question, get an answer, but write down code examples and documentation. And it's like a collection of smaller blog posts where you can look things up. They have like categories, something for beginners, the things that are missing on cppreference, for example. But it's still in beta, so there's not so much content yet, and it's not. I didn't find it. There's no apparent order, so you don't know what to read first, what to read next. But still, I think it's something where one could, we should monitor. We should see how it turns out in the long term. So this is just pure fantasy. This is what I'd like to have. What I'd imagined like a year ago when I think it was John and me who wrote on Twitter on the eve of C++ 15 about learning and teaching and what we'd like to have, what would be a good resource to learn C++ from, to learn anything from that is changing as fast as C++. I'd like to have something like a wiki blog thing like SO documentation where you can write small articles. But with an additional feature where people can go and say, well, this is the line you should read. This is the first page, second page, and gather these articles to essentially bind a book out of them. Maybe not only in one dimension, maybe in more than one dimension. So you have like, read this from there to there, so you have the information you need, but if you are more interested in this single topic, here are further references where you can read more in these pages. Essentially not just a collection of links to different blog posts all over the internet, but a collection of information where you have everything in one place. I'd like to see an aging mechanism to find the things. If you have a page that hasn't been touched for 5 years, there's a good chance that this page might be outdated. So you should have something like a marker that says, right, this page is quite old. Maybe someone should look at it and update it, or just say, okay, it's still relevant today like it is. Of course, as wiki, it's still a community thing, though. So you still have the, like in the forums and Usenet, the discussions. And well, I think it would be a nice experiment to set up something like this, but it also would need quite a few contributors to actually gather the information in the first place. So that's all I got. Does anyone have questions, ideas? Yes. Do you? Oh, thanks.
Please raise your hand if you have questions.
Yeah, so what I observe in a business is that there is some light of programmers who follow the standard, and there is all the rest, the dark matter. They don't like to talk with each other. So basically, you have a ghetto of these good programmers and the rest. And do you have any thoughts how to solve that? Because it's easy to blame them.
It's of course, if they don't want to, you can't. It's hard to make them something do that they don't want to. If they don't want to learn new stuff, then you can't only do so much. But just sitting in each corner and not talking to each other is, yeah, of course, you can try to convince them. Just send them some links to watch something, maybe some conference videos or something that's easier to digest maybe than a standards paper. But I think communication is and showing them how beautiful modern code can actually look like.
That's easy when you are in one company, but then what's happening actually, like these good programmers is migrating to a small company where there's more good programmers.
Yes.
And then the rest is staying there. And how to attack that problem, because that's it.
I think that's...
It's not mine, but it's like, I think it's easy to protect these people and say you're ugly stupid. But how about us? So should you, as a programmer who care, try to do something about it? It's easy to just ignore it, but would it be any better if you do so?
I think that's the hardest problem to reach out to those dark matter programmers to actually make yourself known. And I think it's if we have this one single point where, for example, if you have someone like us, can I get a reference? What is a good book for C++? You get like 200 suggestions what you have to read. And I think if it just is common knowledge that at isocplus.org, for example, is a good place to start to get new information about the language. This information, we still have to advertise isocplus.org and similar pages, but not too many, so that there are not 20 pages out there where you can go, but 2 or 3 points where you just can go and go on from there. So just try to direct all the people that are interesting and actually interested in learning more, try to direct them to one place from where they can go everywhere they need to go.
Yeah, and then just to answer your question, in a different dimension, it's like, it's my problem because the people who write code, and I may die because of this code. So that's serious. There could be more questions. Yes, sorry.
Okay.
No, it's not a question. I just would like to add something. A good resource, a good teaching resource is also doing coding katas and coding dojos.
Coding dojos, yes. Definitely.
That's a good resource, and I think that you can learn a lot from this. And even if you do it, and then you can compare your solution to other solutions, and you can really learn a lot from this.
Actually, you don't need to do dedicated coding dojos. You also can do pair programming and just code reviews. If you have code reviews and you have someone who writes good and clean and maintainable code and modern code, and someone else reads it, it's just the possibility to learn from other people's code. What we had right now, yeah.
This is continuation of the first topic, basically. So I've been working in the industry in C++, writing C++ for over like 16 years now.
Okay.
And I have never met a dark matter programmer. I worked with people who solve business problems, and they solve them the way they did like several years ago, and they go on. But it doesn't mean that they are dark matter. They are solving problems, and they are making money for the employers. So the company actually is doing all right. So the first and primary question is to prove to the company that you can create more value by applying new features. This is the first.
Yes.
And when you have your client, employer on your side, then people usually will lead and will follow your lead and go into new stuff. And I think the presentation is mixing up two topics. One is educating of the fresh students, so somebody who never knew programming, and the second one is keeping up with the knowledge. So I think this has to be a bit separate.
Yeah, okay.
That was my comment.
But with the dark matter programmers, I don't actually mean programmers that do nothing, but I think it was Scott Hanselman on his blog who kind of coined the term. It's about programmers who you don't see directly. You see the results, you see the products they ship, but you don't actually see those programmers online in conferences and so on. This is a good question, yeah. Is this a problem?
So, I missed the first few minutes of your talk. Forgive me if you covered this, but it seems to me that the most people who are going to see your talk right now, everyone who's seen your talk is in this room right now. But more people will see this talk online than see it in person. And I think there's a lot of very, very good content about C++ online in videos. So you talked a lot about things we could read about, which is really valuable. But I think there's a lot of material that's from this conference and from other conferences that is going online that's really high quality material. And the other thing I want to mention is if you go to the ISO cpp.org, there's a list of user groups. There's almost 100 user groups in the world now. Many of them are not terribly active. But I think there's more opportunities for online face-to-face discussion of C++ than there has been in the past. And I think that's really,
definitely it's evolving.
That was the comment.
It's getting better, but we still have the people who kind of know from the past that there is no C++ community, so we have to get the word out to them to show them that things are changing and that there are those resources.
Hi, I teach C++, and I still write my own courseware. The main reason is there are lots of resources, but there's very seldom a good reading order. And getting a good reading order is very difficult.
Yes.
No forward references, and tailor what you teach to a specific domain. I teach mainly embedded.
Yes.
And most books don't focus on that reading order.
Exactly, yeah.
So I agree that especially talks like this are a very good source, but mainly for advanced programmers, not for beginners.
Mm-hmm.
So if you want to mean anything for poor teachers like me, focus on that part. And that's not the very sexy part.
Yes, okay.
And there's a difficult balance between teaching and saying, see this code, believe it, you have to do it that way, and being, let's say, bit level correct.
Okay.
This does undefined behavior interrupts and it doesn't. You shouldn't tell that on the first day.
Yeah.
But you should have an executable program on the first day with some parts they don't understand. And that's a delicate balance.
Yes.
So teaching things to novices is very different from the good conference that teach new things to experienced programmers.
Definitely, yes.
Hi. So taking a trip back when I was at university, unfortunately we didn't get to learn much C++, and the prevailing sentiment from the people that were teaching at that time seemed to be that it was just too complex for essentially introduction to programming. Do you think that moving to modern C++ has made C++ any less complex to teach? Or do you think that having a large set of core guidelines and modern C++ features which are fundamentally aimed at more difficult generic programming concepts makes it easier to teach or more difficult to teach?
I think that some of the features made it easier to get started with C++. You don't, in a I don't know, 1 year, 2 year, 3 year course, you don't get to teach anyone everything of C++. But you have features that make C++ less complex to start with. For example, I met lots of people who had some C++ courses in university, but moved to another language or doing something completely different now. And when I tell them I'm a C++ programmer, they talk to me, oh, the pointer thing. Yeah, well, modern C++, you don't have owning pointers, you just use only free pointers. You don't do pointer arithmetics anymore, especially if you use the core guidelines which discourage pointer arithmetics. So if you don't start with pointer arithmetics on the first day, it's considerably less complex in the first days, I think. So yes, you have new features that make C++ as a whole more complex because those features allow much more to do. But the learning curve at the start is less steep than it was before, I think. Yes?
Yeah.
I disagree on this point somewhat because, as Björn said just now, C++ is a low-level language. It's close to hardware. You understand the hardware to understand the language. So that's why simplifying it doesn't do good for learning C++. C++ has a steep learning curve. You just have to accept it.
Okay. Well, but you also said you have all those abstractions. And many of these abstractions that are new in the language can actually do something to delay the learning of this pointer arithmetic. I'm not saying that you don't have to learn that it's someday, but for example, if you use standard vector, it's much easier than to use a C style to allocate the array and not forget to deallocate it later. So I think those abstractions, those zero-cost abstractions, help you to stay close to the hardware, but to make it less complex in the first.
You can use vector with your first C library, which requires a passing a pointer. But then
yeah, of course.
Instructions are very broken.
Yes.
Why I think you have to understand.
But staying close to the hardware isn't a necessity for the C++.
Excuse me, I have the microphone, and I thought we should use it. So raise your hands, and I would say we take a thought in a way that can you ask your question?
Sorry for the high priority interrupt. So I wanted to refer to what Wouter just said about teaching that stuff. I mean, most people on conference like here are trying to talk really sophisticating about special features of the language. And although I do agree that kind of this is pretty interesting and could also be interesting for people getting into programming, I see most of the problem there that, well, plenty of the people that are familiar with the language and the features of the language are not, maybe, I would not say not willing, but they are not giving their knowledge away to total newbies. Well, I think that's so the point where people enter the programming stuff, they always get taken by the hand by teachers that are not that sophisticated in the language and maybe are not just that good. So, yeah, except for Wouter. Our interns are really good. Yeah, so what do you think can we do to encourage more people that are actually good to go out and teach basic concepts and not just the higher level features? Yeah, there are some new features in C++ L 11 and 14 and 17, but that most of the time that doesn't serve the newbies. So what can we do to encourage more people to teach the basic concepts?
That's a great question. I don't have a good answer right now, I think.
No?
Hi.
Hi.
I just wanted to say, as a person who also learned C++ at college years ago, and then did something completely else in different programming languages, and now I'm coming back. Well, a lot of things have changed, I must say. So I'm trying to learning modern concepts, whatever we define as modern. And I must say that I would really appreciate something like the good parts that were mentioned. I think it's a great idea because whenever I submit my code for review now, my reviewers are going to argue forever about how the problem should be solved. And it's not about the solution itself, it's about implementation details. And it's frustrating as hell because I mean, there's so many ways you can do one thing that it makes people very opinionated, I think, and they can argue forever about it. And I think that's the biggest struggle in this community, honestly. And that's why I think it's nice when company sets up some guidelines, like what people should, and it also can be encouraging to like maybe apply modern techniques, like to have these guidelines. But as a, well, yet again, beginner in the modern C++ world, I would really appreciate I don't know, some maybe subsets of techniques like I could use for starters and then maybe work on top of it. I don't know. Is anyone even trying to do it? Like, you know, because whenever I ask a question, I get millions of answers and I'm just even more confused.
Well, I think you have Bjarne's book, not the 2 of C++, but Programming Practice. No, not the 2 of C++. The other one, the Swan book. I think he called it the blue one. Programming Principles, Learning with C++. So there might be this might be a good resource.
Hi.
Hi.
I think that a lot of programmers actually are already in school. So there is information science classes in school, and people or kids start programming in school. And I think we should also think about what programming languages is good for our children. And do we have a concept to bring C++ to children, or is that too ambitious or whatsoever? So this relates to the question of him who asks, is C++ still too difficult, for example, for school?
Well, I think it was in CPPCon 2015 where Kate Gregory held a talk, Stop Teaching C, where she covered part of which I touched on one of the slides, that you don't start with C and then go on to C++ 98 and then go on to C++ 11, but start with modern C++ right away. And in that talk, she said that she is teaching her children who were like 8 and 10 to program with C++. So it seems to work.